have now um, the next presenter, and we're happy to have Dante Zeng from LONGi.
Hi,
And hi,
uh,
Dante. And
hi.
Dante will talk about cradle to grave, how LONGi secures HIMO X10's full life cycle reliability. The floor is
Okay, I
yours,
share
Dante.
my screen.
Please go ahead.
Yeah, yeah, I'd like to share my slides. Everyone can see that?
Not yet.
Uh,
Here we are.
is that okay? Yeah, okay. Thank you. Yeah, I'm Dante from the LONGi DG Business Group, the Distribute Business Group, and I'm coming from the marketing department. Today's topic is about the cradle to grave, how LONGi secure HIMO extend for life cycle reliabilities. Because in order to fulfill the demand of the distributed market, LONGi just launched the HIMO X10 just 10 days before under the witness of the tennis legend Roger Federer and also the global tennis audience and fans in the Shanghai ATP Master game. So but how could we guarantee the customer need and customer demand in such product? And today I would brief uh, interpret it. So our content we divide into three parts. First, we gonna focus on the distributed market reliability issues, and second, I gonna talk about how HAMR X10 solve it. And the third part, I gonna brief introduce except our product, what can we do to guarantee the customer reliability and their value? First, we should say the distribute market issues. I think the hotspot is a big one because I think for other reliability issues, we have some certain tools or solutions to solve it. Like we can replace the glass, replace the film, replace the junction box. But for the hotspot and shading questions, it haven't been solved yet. And I think for the industry, we have like a half cut technologies to reduce the current, and we have like the bypass by, bypass diodes in the junction box to give some certain bypass function during the hotspot, but they cannot solve the key questions. And the hotspot is always coming from the shading, and it will lead to the localized high temperatures, and finally have some will lead to the huge degradation or even some fire accident and make huge economic loss and the safety loss. Except the hotspot, we can say that in the distributed market or in the global PV in installation environment, there are a lot of factors that affect the PV's reliabilities. It's about the dust accumulation, about the vapor intrusion, about the frozen, about the UV, about the temperature difference, and about the mechanic strike. There are a lot of things. And besides this environment things, we have like the damage coming from the people. Like after the module leave the factories, it will have a long way to go. And during the transportation and also the installation process, there will lead to some damage, some hidden crack is also another big part and make the module failure. So that's also should be grasped some attention. And and it's a summary, and there are some typical module reliability problems, and it's always coming from like hotspot is coming from the dust or the bird droppings or some shallows, and the DH and PID always coming from the vapor or some negative bias voltage. The UV ID and the TC questions is coming from the temperature and the high energy irradiance, and for the mechanical braking, they're coming from the transportation or installation usage impact or some stopping or some standing. There are a lot of things. And we divided the customer reliability issues into these four parts. And then we're gonna come into how the HIMO extend could solve them. First, I'm gonna give a brief introduction about HAMR X10. HAMR X10 has a very high level power, like in the current 2382 millimeters size, we can achieve like maximum 670. But it's not about this topic. We're gonna focus on how the HAMR X10 guarantee the reliability at the beginning of the module design, and it's called back to the topic like the cradle, because for LONGi, we always consider the module reliability and the design phase. So that's a big one. So we deconstruct the module, we can say that there are three key factors that affect the module reliabilities. They are the cell technologies, the wafer, and also the encapsulation. So for every part, the HAMR X10 have their own advantages, like we adapted our HPBC second generation cell technologies as they have a lot of talented in solving the reliability issues. And also we adapt our TaiRay wafers, which is very it's a cutting edge wafer technologies. And also about the encapsulation, we have some special module or frame or glass design to guarantee the reliability and this part. So we dig into the details. So for the hotspot, the HPC second generation have a soft breakdown design and the backside because we are the BC cell technologies and passive and active side and all and the back. So we can do such a soft breakdown design. It's basically just integrated the bypass diode and the backside and not you just don't need to put a real diodes and the junction box because for the every cell we have like internal diode, and when the cell meets the shading or the dust accumulations, the diode activates and it will have some certain bypass functions, and the overall temperature and the loss will decrease. Yeah, yes, there are some examples because in the distributed market, in the distributed environment, there are always a lot of shadings coming from leaves, coming from the dust, coming from the snow, coming from like some external building shallow. I don't know, but there are a lot of things. But for traditional modules, they can only when like one piece cell was shaded, it's will lead to the entire string to lose their power. And but for a HAMR X10, our internal diode function, internal diode this special design, we can reduce the effect about shading and guarantee more than we can take back more than 70% loss, and we can guarantee the customer's generations. And also for the temperature, because I think the power loss is just one part, but for the temperature, it really threats the people's safety and also your economic safeties. I think for the traditional modules, the maximum hotspot temperature could achieve more than 170. And for our HAMR-X10 or for our HPBC second generation cells, we can reduce the temperature more than 28%, which means in the real numbers, we can reduce the maximum hotspot temperature under like I think it's 110 below, and I think this about 70. There is about 60 Celsius temperature gap, and this gap will largely rise the risk coming from the shading and guarantee the guarantee customer safety. And also for except the cell technologies, we have our anti-dust design. It's a module level design because we remove the A side frame from the modules, and when the dust accumulates at the bottom, it will falling down naturally by the gravity or by the raining, by the water. So it's a it's seemingly very small innovations, but it could truly affect the module efficiencies and also the module safeties. So after the hotspot, we can turn into like the DH, UVID, and TC. I put them together because I think it's for the industry we already have some certain ability to solve them, and we already know how it happened, and we have some technology to get them done. But for the module levels, we can see that their damage from my own perspective, is very close. It's always coming to lead to the film yielding, lead to the large power generation loss, lead to the leakage. It's quite same, but it's coming from different reasons, like the UV is coming from the light, and the high temperature is coming from the temperature, and the humidity is coming from like the environment. But they always lead to some like some some similar degradations, similar loss. And for the HPBC second generation cells, we can largely reduce the UV degradations. I think the I think for all we all know that the TopCon have experienced a very strong, very terrible degradation issues in the last year, because I think from the technical side, it's coming from the front side diffusion part, and the aluminum silver past the connection to it's not very good to connect to the wafer, and it will lead to some leakage channels, and will lead to the degradations, and also lead to the UVID problems. But for our BC technologies, firstly, we do not have the high temperature sintering and front side, so we won't lead to any leakage channels on the front side. And for our backside, we have the channels, of course, but we have our bipolar hybrid passivation, and it's very advanced and can reduce the current loss. But for TOPCon, they just have the unipolar, like they just have their own tunneling oxide passivation at the backside with the N-type diffusion. And from the front side, they just have the normal P-type diffusion without any advanced passivation. So it's a huge difference. And our HPBC can largely reduce our UVID questions, and also reduce our DH questions. But but for TopCon, we don't know that exactly. And it's of our first part. Also, besides our cell technologies, our encapsulation is also very important, but it also attract the LONGi's colleague attentions, because we have our high density packaging, and also we adapted POE encapsulation film, because we all know POE is not an acid materials. It can largely reduce the water intrusion, and also reduce the possibility to achieve the acid environment internal the inside the modules. And for the electrodes, we use pure silver, because the TOPCon issues DH question partly coming from they not use the pure silver, but or use the silver doped some aluminum to achieve the better electrical connection. But it also lead to the higher corrosion questions. But for our BC, we adapted pure silver electrode path both as positive and negative. So we do not have that question. Also for our bipolar, as I mentioned before, we do not have that much leakage channels, and we have very high level open current voltage. And it's for this full part, we can guarantee the reliability and the packaging side. And another part, I think, is brand new findings, but it's also very reasonable, because we found that in the real case, also through the theoretical calculations, we can find that our HAMR X10 modules have like average 0.5 Celsius lower operation temperature than the normal module like TOPCon or HJT, because we just try to analyze it. It's coming from our high efficiency, because we know that when the sunlight come into the modules, the energy will divide into two parts. Where some of them like around 25 will turn into the electrical energy and be transmit out the modules. But most of them will turn into the heat and rise the temperature. But for our HAMR-X10, because we have like 0.5 higher efficiency, so we can absorb more sunlight energy and turn into electrical energy, and we will reduce energy through that wave. And the temperature, we just say that is 0.5, is not that high enough, right? But this 0.5 will lead to like a lower agent of the overall materials, like the film, like the frame, like the glass, like the ribbon. They're all affected by temperature. If we can drop the temperature down, we can try to extend their lifetime and reduce the degradation, by the way. It's a very important part, actually. And because we have that technologies, we can achieve like a very high level test performance. And through this, I think it's 3 times stricter standards compared to IEC. We can have better performance compared to the traditional TOPCon. And for the last part, it's about mechanical braking. Because the mechanical braking is when the braking happens, it's not very easy to be observed because it's like the hidden crack is not that big. You can only just put the module under the EL test machine. You can see the crack, but for your own eyesight, you can see that very obviously. But the hidden crack will lead to a lot of things. It will lead to the hotspot, will lead to the degradation. It's a minor, it's a it's a small damage. It's a small damage will lead to huge loss. And for LONGi, we launch it as a system level resistance to the mechanical stress because we have our TaiRay wafer. TaiRay is basically we change the dopant materials and some certain fluid dynamic technologies and try to reduce the mechanical strength by the 16%. And also we choose the thicker wafers because I think for the industry, for the average wafer thickness is about like 120 millimeters or even thinner because they all want to reduce the cost and especially in this cost competition time period. But for LONGi, we always choose like it's about 10 or even 20 millimeters thicker than mainstream cells. And for that, we have our BC one line. It's very typical, very symbolic. It's a one line back contact winning structures. It will disperse the stress and reduce the cell edge stress by like close to 50%. The three add up together, the TaiRay wafer, the thicker wafer, and the BC one line structures, we can achieve like a higher mechanic stress resistance and help customer guarantee their wafer quality and reliabilities. And, for the last one, I think the zero BB structure is very famous in the industry for these 2 years, and I think a lot of companies just announced that they have these technologies. But for our HAMR-X10, we really adapted into our BC cells. It can not only increase the efficiency by more than 5 watts in the middle-sized modules, and it can also increase the reliabilities. Because at that time, we remove the bus bar, the ribbon directly connect to the fingers, and the stress are largely dispersed through the ribbons, and it's not very easy to get broke compared to the traditional like SMBB, the super multi BB. It's another sport. It's another tools we can help to reduce reliability. We can increase the module mechanical stress resistance. And I think for the technical part is over. We have a lot of technology, so we can guarantee the module's reliability through our cell, our wafer, our encapsulation. But except the technology, the product itself, I think there are more things the manufacturer should have to guarantee the reliability. First is about the financial, because I think if the module our module is broken and your company is disappear, the customer have nowhere to repair or get some help. So the financial is a very important part because they guarantee your customer lifetime and guarantee the customer guarantee that when the customer meets some reliability issues, they can connect to the company and the company can help them to solve it. So it's very important. And it's also it's LONGi's ideas that the enterprise should survive longer than its product. So it's very important. And also for the LONGi, we have the global R&D production and also our sales service team, which means in for our global customers, for most places, you can directly find our local team to help you repair your modules or replace your modules if you have any issues. That's our second extra technical solutions. And for the production and test standards, it's also very important because but it cannot be directly show up and the design. It's our topic, I should mention again, it's a cradle to grave, which means after you sell it, you should always guarantee the reliability. So we have our financials very high. We have our very financial level, very good financial levels. We have our global service team and also have a very strict raw material standards because we can guarantee the module quality in every aspect. We always test our glass, test our junction box. We even connect to like third-party team to directly make the standards, and we do a lot of things besides the technologies. It's our material, and we have very strict test standards because for the IEC, it's a have like the global standards, but for LONGi internal test, our standard is much stricter than IEC, and the frequency is also much more. The frequency is also very often compared to the industry. For our own research, the industry just test their module like quarterly or even never test their modules after they sell them. But for LONGi, we always test our modules quarterly or even monthly to try to guarantee our every module is under the standard, is qualified. And last one is our production level. I think the production level is another way to represent our customers' technologies levels and also our determination to guarantee the product because we put all the money, a lot of attention, a lot of people on the R&D, try to improve our manufacture levels, and we got a lighthouse. We are the first lighthouse manufacturer in the world, and we can largely reduce the yield loss and energy consumption, a lot of things. It's another side to prove our reliability for the customer and the product. Yeah, that's it. I think I finished my discussion and be free to ask me everything. Thank you.
Thanks, Dante. Great stuff. That was a great presentation. Good to see that the LONGi representing big manufacturers is taking so much care about reliability. If there might be some questions in the chat, actually, I think there were one or two. You might want to, I think there was something about diets. You might want to look into that and answer it there, that would be nice. You know? And I think there
Yeah,
might be
thank you.
also some more. So please take a look. Thanks again, Dante.